Our next speaker is Michael Runningwolf. He is an Indigenous AI ML researcher working with immersive technology and artificial intelligence on the reclamation of Indigenous language. Languages are disappearing at the rate of thousands per year. And so this kind of work is very important, and it's also very personal for Mr. Runningwolf and for myself. I have a large portion of my family who live on reservation in Lumbee, North Carolina. And so with that in mind, Wopila Tonka, welcome, Michael Runningwolf.
Next for you so I can help you. Okay. So new automatic speech recognition system. Voice AI control. Okay. I'm Michael Runningwolf. Thank you for welcoming me and to my host, Morgan University. So I'm Michael Runningwolf. Next slide. I'm going to be speaking about AI research, but first and foremost, let's start with who I am. I'm Lakota, Blackfeet, Northern Cheyenne, and a little bit of British princess, and so in my cup here, I have some Earl Grey, like literally. One of my ancestors came from England and then made his way to Montana way back when. And so what you're seeing here is my wife's encampment in Montana on the Crow Reservation, and this is a Crow Fair, and it's the largest teepee encampment in the world. So we are the stereotypes, the quote unquote feather native. And next slide. And my work, the Crow, Cheyenne, Lakota, and Blackfeet, and many other indigenous communities in North America are facing language loss. And so what you're looking at here is language families across North America. The largest language family in North America is Algonquin. And so you can see a lot of languages here on the Northeast are, Wampanoag, Mohawk, Seneca, and they go all the way up, and these language families go all the way up to the Mountain Rockies with Cheyenne, Blackfeet, and other languages out there. And it's probably the richest, most diverse language family within North America. And then you also see other large language families, including Dene languages or Athabascan languages. So you have Navajo languages in the Southwest, kind of this pinkish red, and then up in the north, like Gwich'in languages and others like that. And what you'll notice here is that the white represents languages that don't exist anymore. The zones where the entire language families aren't present anymore. And so this map is essentially a map of colonization. What you see is with Manifest Destiny working its way west, language loss is more prevalent here in the East, but we have high diversity of languages in the Northwest. I am imagining that pre-contact, it looked a lot like the West Coast, where we had a lot of language families across the coast and all across the entire continent. But what we have here is that we have entire language communities who were pushed out. A lot of us lost our languages, a lot of us, entire peoples disappeared. Next slide. And so what I've been working on is automatic speech recognition for indigenous languages. And what does that mean exactly? Being able to create speech to text is a complicated task for languages, just in general. It's relatively a recent phenomenon, probably since the 2000-ish, 2005. I'm old enough to remember Dragon Nuance, and that just barely worked. I don't know if you guys, some of you professors remember that, trying to transcribe your notes. It just was terrible, honestly. And that was using conventional AI, hand-coded. Someone went out there and collected specific phonetic data for English and compiled these hand rules. And that kind of research took decades. That kind of work started in the 1960s and really was kind of sort of useful in the mid 2000s. And most recently with deep neural nets, that's really become that we've seen this explosion where automatic speech recognition and natural language processing has bloomed. But then if you start to point these technologies at indigenous languages in North America, and actually indigenous languages who are not European, you find that these technologies have a fundamental flaw, or rather there hasn't been research done on how to do non-Western languages. And so the scientific problem here for you language nerds, and how many language nerds do we have, by the way? Yay! Awesome. Usually there's only one of us, me, standing up here. No, that's good. And what's going on here is that Western languages are actually kind of boring. There's this phenomenon called polysynthesis in linguistics, and this basically means that languages, you have this basic concept of a morpheme, which is the smallest amount of noise that conveys meaning. And so in English, you have the red car, and you have three morphemes there, conjugation of to be, a color, and, the subject, which is an automobile. And if you add S, the red cars, the S is the polysynthesis. And before indigenous languages in North America, and actually most of the world, African languages in South Asia, languages across, the Pacific and the Caribbean, in South America, what you find is that most languages in the world have high polysynthesis. It's, for whatever reason in history, European languages lost a lot of that. And it's a gradient. Like with anything, it's not a binary construct. English is particularly isolate versus languages in North America. I mean, in North America, we don't exactly know because a lot of languages in the world are under-documented, but we probably have the most polysynthetic languages here in North America. And modern AI has been built in the Western European context. And so the AI doesn't really account for the high polysynthesis you see across the world. And that's not to say there's also more isolate languages out there, languages like Mandarin, some Pacific Islander languages, they have very low polysynthesis as well, which means that you can use the modern automatic speech recognition AI strategies on these languages. But when you start looking at languages that have high polysynthesis, like your language, it's not going to work. And this has been shown over and over and over in the literature. And then it's actually kind of a trope now. Because I'm starting to get kind of famous by people who are really nerdy like yourself, like this table over here. People send me articles of like people trying to get ChatGPT or Llama to speak indigenous languages. And basically I should probably write a paper eventually. It doesn't work because even ChatGPT and these large generative AIs, they have a fundamental conceit that you're speaking some sort of language that's similar to English. And there's a reason for this in AI, and it's because, English speakers are the ones that create AI. And talking about bias, like when we talk about biases in AI, like the prior speaker, it's deep. It's within the fundamental math is biased towards a certain perspective. And if you only speak English, like most Americans do, and you go to MIT and you learn about, or go to other universities like Carnegie Mellon, you have this assumption that English is enough, and you build AI that's really vibrant and work well designed, but you're focusing on one European language from a particular continent which lacks phenomena that's present across the world. And so what we're talking about here, and this is an example of macaw, and you can see this is one word. So entire phrases are composed of highly polysynthetic words that are constructed in a very contextual manner. What I mean by that is the example of the red car. A Salish language on the West Coast would impart directionality upon it, like it's it gives it vector distance. Like I can say embedded within the red car would be, it wouldn't be just simply the red car. I would attach suffixes and prefixes and other morphemes within the word, kind of like train cars, and say that the car is to the north of me, it's owned by an acquaintance, and it's outside of hand reach distance. So if it was in Montana, I would embed that it's west of me. And there's a lot of languages like this. And the whole, like, it really changes your worldview, like the whole idea of left and right. We were working with a language called the Gwich'in, and they don't think in terms of left or right. They think in terms of upriver or downriver. And so when you say go left, they're going to look at you confused. What do you mean by that? And if you work in languages that are Aboriginal to Australia, they work in cardinal directions. So imagine if you every day, and there's some of us who can do that if you spend a lot of time in the woods or in the, hiking around, but they do everything in cardinal directions. There is no left or right. There's eastward, there's southward, which part of your body is facing which direction. And so these languages, not only are they fundamentally different, they embed the cultural nuances of the people that speak with them. And so if you go back to that, don't do that, whoever's the AI over there, but if you go back to my original slide and remember it, we're looking at entire classifications of modes of thought that are disappearing. And unfortunately, we're looking at language like, oh, yeah, can we go one more slide? I think they're missing. Yeah, this is the slide I thought you were looking at. Yes. So, yeah, and so what we're looking at is language loss, that not only are we losing a method of conveying information, we're also losing a way of knowledge, losing a way of perspectives, and it's actually genuinely heard in science. Because we're not researching this. And yes, going to the next question. And so the question arises, how do we fix the situation? Like I said, we could do it the conventional way, the non-deep neural net strategy, but that takes decades. Like the first version of Siri, it took them probably 5 to 10 years, built upon decades of research, of painstaking work, where the first original Siri, Apple's Siri, was built upon the assumption that some human out there was hand encoding waveform analysis. I assume a lot of you are math nerds. Imagine doing just a lot of calculus per noise and then assembling that into like a mathematical model of language. It's really tedious and takes a long time. And you can't expect a community of a couple thousand members to involve of it. But so you need to do deep neural net research, but we have barriers. Next slide. And of course, there's also the biases, like I mentioned, embedded in the AI. We're not going to spend too much time about it here. Like, if you ask Dolly, this is actually a year ago, you can tell how quickly Dolly moved. And you ask the question, Americans at work, and you go to the next slide. Ask Germans at work, and I'm married, my wife grew up in Germany. I can attest they don't wear a lot of color compared to us Americans. If you go to the next slide, this is what it says for us. And to an extent, it's changed, but it basically still gives you, another coded bias, just basically repeating. I think the prior speaker said it better. We're encoded within the AI as a bias of our reflecting upon how we think of the world and a dominant culture's view upon the natives. And so the next slide. A bigger component of this is also our cultural loss. So Native American art and culture is spectacularly and fabulously marketable. And so a lot of our material culture, when I say material culture, or artifacts, the things that we make, is valuable from a perspective, not only valuable to ourselves, obviously, but valuable from a monetary perspective. Like, we lost a lot of our culture. A lot of our culture is sitting in museums, including in the Smithsonian. So what you see in here is Sitting Bull's winter count, and we'll probably never have access to it, because how likely is it that the federal government is going to give this back to us, because it's culturally significant? But now the Lakota are being excluded, my family, from interacting with their own culture. And so a component of this is that as we're building AI, we need to be careful that we're not giving up more of our culture and locking it away into proprietary systems. And next slide. Another, like, so as we are thinking about who will protect our data best, it's ourselves. But unfortunately, we make up 0.01% of the computer science PhDs being awarded year over year. We're lucky if we create 2 PhDs. Sometimes there's 0 PhDs. And computer science are related fields, fields that you would be able to do AI in, including data science. I know the only tenure-tracked Indigenous professor of computer science. He's probably the first, and he just got his appointment last year. It's like that recent. It's really within the last 10 years that we've been getting PhDs at all. And so we have a clear barrier. Like to be on par with the general population, we need to be generating 20 PhDs per year, and that's, I mean, that's not a lot, but for us it would be a significant population burden. But we're just facing the intellectual talent barrier. Next slide. Another component of this is that we are diverse geographically, and we're spread across the continent. Like what you're looking at here is federally recognized. This is excluding communities who are urban, but these are federally recognized lands. And first thing you see, America's big. The United States is huge. It's hard to walk across America. It's hard to get over here. I flew in from the West Coast, and I get here to like 3 a.m. last night. And the thing you want to show you with, illustrate with this is that we're dispersed, we are geographically very different, and we have different values. Like the cultures in the Southwest, the big red spot area down there, the Navajo, Pueblo, Zuni, a host other tribes, including the Apache, they're very different from us in the Mountain West. If you go straight north, we don't associate with them. Not because we don't like them, it's just that they're very different from us. They hold different cultural values. They do very different ceremonies. They speak very different languages. They do find tall Lakota people romantically interesting. That's sort of a phenomenon I've noticed, because they tend to be a little bit shorter, but that's a slight bias right there on my part. And so the Lakota are straight north of the big, large red area, and the Cheyenne and the Blackfeet, and we're all very different. You know, like we're talking about, you know, thousands and thousands of different communities spread across different reservations and across the continent, and we hold different values, and we're dispersed, and we don't have common infrastructure the way you would normally think like of a society. And so the barrier here is that we don't have a consensus view on what is bias necessarily within ourselves. So a top-down approach just innately will never work. Like I can't impose, you can't say the Michael Renewolf strategy is ever going to work for the Napi or the Seminoles or the Tatavian in California. We really need hyper-local solutions that isn't top-down. Like a strategy that works for one community, including the African-American community, won't work for all of us. It may work for some of us, but it's not going to work for all of us. So when you're talking about diversity and DEI and trying to uplift Indigenous communities, you got to remember there's hundreds of us who don't necessarily like each other and won't embrace outreach similarly. Like if there's success in one area, you can't expect it to be replicable. You got to get really deep community buy-in. And so the last slide here on the barriers here, like what you see here is that you have communities being hemmed in by a barrier to the technology. The fundamentals of the technologies do not allow us to build AI that really works for us. The big data phenomena, you know, data is the new oil. It's a commodity. The Forbes magazine, The Economist coined the term. And what you're finding now is that there was like a big controversy a couple of months ago where Michigan State University was caught, or a subcontractor was caught selling audio data for $12,000 per hundreds hours of audio, and none of that's going to the students. And it's similar with Indigenous communities, like where we have researchers coming in, collecting our data, we're signing waivers, And the universities are typically, or the corporations or the governments that we're working with, resell it to data brokers because it's valuable. And the only way we can really change this is that we need talent, but we don't have talent. We have a very weak talent pathway. So what do? Next slide. We got to do it ourselves. What you're seeing now is an emergence of vibrancy within AI. So these are some of my colleagues at Tehiku Media, worth Googling, by the way. In 2018, they began this research project, this wild idea of what if we build AI for ourselves, because we refuse to work with big data, with big tech. We don't want to work with the academies within New Zealand, and we don't trust the government as a foundation. And they, with a very small shoestring budget, taught themselves how to build AI, collected their own data so that they have total governance in them, and taught themselves and said, we're going to do it ourselves and impose our own cultural values upon them. So the research that I am conducted has 99.9% been inspired by them. And what's the not inspired by them? The specific technical challenges that you find in North America versus the technical challenges, linguistic technical challenges that you find in New Zealand. Next slide. This is Tehiku Media. So Google, if you see that logo, that's good stuff. They have some, Keone and Peter Lucas have some amazing videos out there. They've done talks. Next slide. And this is my research specifically. First Languages AI Reality. We're working with Mila in Montreal and a nonprofit here in the United States. And we also have some other allies, including Simon Fraser University and other corporate backers and foundations, including the McGovern Foundation. And so how do we counter this? Next slide. So we need to do it ourselves. That's how we protect our data. And we also, going forward, what does that look like when we're protecting ourselves? And I think, and this doesn't really exist, certainly in an indigenous context, but what we need are strong social structures that work for us. Like, we have valuable data. I'm constantly being offered on the order of 7-figure offers to buy our data without permission from our communities. And I would love to harness this interest. It's tempting sometimes because, like with everything, we're always, on the hamster wheel of pursuing soft money and federal grant systems. But there is a value here. So I think with community buy-in, we could build infrastructure, technical infrastructure and policy infrastructure where indigenous communities would be allowed to derive value from their own IP and basically be a data co-op where, minus an overhead, technical infrastructure and paying lawyers, the value of data being licensed would then be injected directly into the communities where they can participate on the community level, and they can use this money and infrastructure to invest in themselves. Next slide. Which includes youth empowerment. Part one of the efforts that I'm working on. So stepping back a little bit. So when I was pursuing this automatic speech recognition since about 2019, which is when I met the Maori, it occurred to me that we should do this immediately. And I said, we're going to find all the native AI researchers and we're going to pull together our resources and do it. And I felt like I walked into an empty room. I started an affinity group at NeurIPS, which is the biggest AI conference in the world. And there's just very few of us. Like, I estimate there's probably only 12 of us. So we have a career pathways problem here. And so to address that, me and some friends, primarily my friends, I'm not that smart. I just give presentations. And got together and said, why don't we teach the youth to do this? Because that's where it starts. We don't have undergrads who aren't going into grad school, who are getting PhDs. And then we did quick surveys, just some informal surveys, and the high schoolers don't even know that computer science even exists. So what we did is we started the Lakota AI Code Camp, where we teach them basic computer science, teach them AI, and teach them app development. We're not trying to create fungible engineers, we're just trying to get them interested, that it's not scary. Like when they see matrix math and calculus, they don't freak out and run away, because you'd be surprised. We had 13-year-olds just gobbling up multivariate calculus and the gradient descent function, and of course they don't fully understand it. You couldn't get that, but they were hungry for it. And now we have our very first cohort of high schoolers who are now in computer science undergraduate degrees as we speak now. And we were told from AI specialists and educational specialists that you can't do this. You can't teach a 13 or 14-year-old, a 15-year-old, or even an 18-year-old multivariate calculus or machine learning and computer science, certainly not at the same time, because your brain's going to fall out. And we said, well, no one else is going to do it. We have the money. That was also a big impetus. And our best programmer was a 13-year-old girl, a Lakota girl, who was food insecure. One of us asked her one day, well, like, what do you like about the camp? This kind of curious, how's your days going, that kind of thing. And her response was, I like that we eat 3 meals a day, because I don't get to do that at home. And this was our best, smartest pupils in the camp, and now is, entering in her junior year, and we're going to help her get into college. And I think we're changing lives here. We're changing perspectives and intervening where it's most necessary when it's at high school. Next slide. And it was quite uplifting. For me, it's a moral uplift, because you take students who had no prior computer science, very little math. Rural schools are quite terrible. Even if you're a regular, even Westerner in Montana, you'll find the school system lacking, and especially so if you're Native American. But for them, at the end of the week, what you're seeing here is week 1, we taught them basic computer science on Monday, and by Friday, they were running their first random tree models to predict basketball. And this group here, these 2 individuals, they came up with a 90% solution, I think. And I don't know statistics of basketball, quite frankly, but they were able to doing data modeling and data science, able to figure out a model using decision trees to arrive at a solution, and that's quite amazing. They had no prior computer science, no prior programming, no prior data science before this. So next slide. And so the goal here is that we need to make the technology work for us. And we need to fund the investment into the technology through something like a data co-op. And to enable all of this, we need talent that isn't external to us. We need to bring these within to the community, that also works at scale, not in the terms of traditional scale of big data, large, we're going to have a single solution with millions of users. We need the opposite. We need thousands, hundreds of thousands of solutions that scale to millions of communities, and empower local talent, similar to what Morgan University is doing with some of the stuff that Mark is doing with their online platform. We need to do that for communities writ large, and with the goal not being that we centralize talent and centralize technology with a single solution, but no, we have a shared common vision that is dispersed and communal and works at a scale, at a small scale for individual communities. And so that, and then to rephrase another way, my goal isn't to be the figurehead of indigenous AI. And there's a handful of us out there. I think we need thousands of us. We need thousands of us across North America, being leaders within their communities, developing technology that works for them. And that's sort of the goal of my ASR research, is that we're not trying to build a singular platform. We're trying to tackle the big, complicated problems that you need to do in the lab and get it into the community as quickly as possible, so that they can remix it, modify it, and advance it for themselves. In the next slide. The general goal being eventually that we have consumer devices in the communities where we have a simple little Raspberry Pi that costs $50, and us natives, we really like cedar stuff and put it in a nice little cedar box. And the eventual goal being that we have millions of these devices catered to small language communities where, as an insurance policy for the future, and embed AI that works for a community and on a little device and put it in grandma's cupboard drawer. And if someone ever wants to learn the language in the future, they just got to pop it open, plug in the USB, and there'll be curricula on there to allow that if something ever happens, which we can't predict, at least there's these devices that are dispersed across Native America. And next slide. And I think, hopefully am I on time? I think, okay, good. Yeah, so I think I am, so the end state goal being that we need to define for ourselves as Native Americans or as Indigenous or as community members of underprivileged societies how we want to interact with the future and how we want to define our future for ourselves. And I think it's attainable. We only need 20 PhD students per year to begin to light, to begin the movement, to light, it's not a lot. We can catalyze a future where communities are defining for themselves what their role is in the future and with advanced technology. And the investment is going to be small, relative. We're not trying to eat a buffalo in one bite. We can bite this off in little bits. And it's totally doable. It's not entirely crazy. 20 people is not a lot. And next slide. And so the thought I kind of want to leave you is that technology that really works for the community has broad impact and has impact that, sorry, it's, kind of the story behind this photo chokes me up a little bit. Excuse me here. Because imagine being able to have technology that bridges goals, and because what happened here was that I was doing the demo of our AI, and naturally, out of kind of the ether, these two little girls who didn't know each other, completely different backgrounds, came up to us and were like trying out the AI, and this little Blackfeet girl and the little blonde girl came up, and they were like, they didn't know each other. They were looking at the AI, and we were like playing with the iPad, and their parents, you could tell their parents really weren't very comfortable with each other, but the two little girls didn't care, and through the technology, they were able to bond and able to and create this connectivity and community that you wouldn't find otherwise. Yes, the technology could be colonial, and if we don't participate in the technology, we're looking at the likelihood of indigenous languages being lost at a large scale. But through technology that's done the correct way, I believe, we can build new bridges and new bonds where we're not threatened by the technology anymore, but we're being empowered and united through the technology. And it's not going to be some singular platform or one singular vision. It has to work on the scale of two little girls playing with an iPad. And so, thank you very much.
Are we okay? We're live. Thank you so much. Do we have any questions or comments or feedback? Every time, and I'm just going to come over and say, Baltimore, stand up.
Thank you so much. This is so inspiring. I was trying to relate to my back home. I'm from Bangladesh, and we have language is very sensitive to us. We had a language movement in 1952. People actually died to preserve their right for language. So my question is, again, this is very inspiring, and the last slide was, it was, yeah. Anyway, so question is, you mentioned that you need 20 PhD to achieve the goal. So my question is, why PhD? Can it be attainable by not saying that it's overambitious, but PhD might take longer to achieve. So yeah, so what is the rationale behind just having PhD, not master's or undergrad, and specialize in AI?
So I used to work at Amazon, big company. So you think about where we want to be, and so where I would like us to be, and this is obviously just counter to what I just said, a singular vision, where we're beginning to transform the fundamental infrastructure of our environment, which is academia. You know, right now, what is language loss looking like now? It's not Google or Amazon or Microsoft stealing our data. It's academians. It's linguists, computational linguists, ML researchers getting their PhD, going to the community and taking their data without, community permission. In the United States, we actually have IP protection for indigenous communities, but you find that a lot of researchers don't abide by that, which is a big problem. And how do we change that? We need to remove the threat by transforming the community of AI practitioners by us having 20, with the 20 puts us at population par. And by the time we have 20 PhD students, that means the environment is so welcoming that we can have 20 PhDs per year. And if you work backwards, it takes, for us, Native American context, 50 of all 50 undergrads who graduate, one of them goes on to gets their master's, maybe 4 or 5 get their master's, and then one of them then pursues their PhD. And so if you get 20, you're looking at producing around 2,000 undergraduates per year to get to that 20. And so you imagine, and only about 40% of us, or actually it's much lower, depending, between 20 and 40% of us who go into computer science actually get a degree, which is quite low, by the way, relative to the regular population. So we're talking about 4,000 inspired indigenous students who want to get computer science degree, 2,000 of them then. And so we're talking about 2,000 families, 4,000 families who are empowered to send their kid to go to college. Or it doesn't have to be college too, it could be community. Most of us go to community colleges first. So we're talking about thousands of families per year, hundreds of communities per year being impacted by the pursuit of 20. 20 is the goal, yes. We don't really need 20 per se, sure. But by pursuing that, we're laying the infrastructure for changing the dynamic of indigenous relationship with technology and the academia overall. Does that explain?
Hi, thank you for a really thought-provoking talk. So I'm kind of focused on this whole concept of indigenous knowledge, indigenous epistemology, and this kind of follows on with the previous question. Academic institutions are also based in Western culture, even HBCUs to a large degree. So if you're talking about how to use these technologies in indigenous ways and transforming the academy so that we can harness the power, how do we keep the sort of indigenous ways of knowing and learning, right? How do we embed those as we engage in this work as educators or professionals in this space, also keeping in mind that although many of us may have been reared in communities, when we get to academic spaces, a lot of that, we have to leave it at the door, right? So my question is kind of, how do you did it with youth, right? Mm-hmm. But just what are some thoughts about how to approach that, even as we think about transforming the academy so that it makes space for and it's open to, and we think about tenure and tenure track and, you know, what is viewed as rigorous, you know, what research methods are acceptable, many of those things are really, they kind of shut down the organic ways of knowing and doing. You know, what are your thoughts about that?
That's a really complicated question that it's very likely the United States will never solve for any of us who are dark-skinned, honestly. Yeah, that's a big problem. I think and I can't speak for others, but I think in the indigenous context, I think just being allowed to participate is a big step, or being invited, in fact. Like, you'll find that it's very rare that you'll find a Native American in the room or being invited at all. You know, like a big struggle I had in big tech when I worked in, and I'm not going to point at Amazon or IBM or the other companies I worked at. It's a problem overall. When you look at, for example, I'm just going to pick on Meta randomly. Meta's DEI report. They have, you know, African American, you know, Latinx, you know, women, LGBTQ, you know, the percentages of their population. And at the very bottom, there's other. And what is the other? It's us. It's Native Americans. You know, like, well, why can't you just say Native American or Indigenous, you know, or Pacific Islander or whatever, or Alaska Native, whatever the parameter is. And then it's like 0%, essentially, 0.001% or whatever. And that's just sort of changing that dynamic, which is a very small step, difficult. And that's like the bigger picture problems. And then going back to your original question of how do we work with indigenous ways of knowing in a system that is inherently hostile? I think we need our own institutions, which we do to an extent, but they're massively under-resourced. We have tribal college university system, which we're very thankful for, but they're underfunded. They're primarily funded through federal grants, and also maybe the tribe, if they have some sort of revenue, they fund it. But on the large part, they're massively underfunded. And that's also the primary way Native Americans get higher education. They go to a community college, which has subsidized tuition, which is embedded in the community. And often the TCUs, the tribal college universities, the TCUs usually are the center of the language reclamation. So that's where you have the linguists, community researchers, you know, like in Montana, for example, if you speak your language and you have a teaching certificate, you are basically considered a professor in Montana, and that needs to be more common. And some states even make that illegal, though. You know, like you specifically are not allowed to do that because of, you know, xenophobia, essentially. And so it's a big problem. We need our own institutions, number one, but they're under-resourced. And you can't get a computer science. There's very few TCUs offer computer science at all, or even IT or any kind of a vocational. They're usually very practical vocational, like a community college. And so our real venue is, you know, state colleges within our, you know, and there are some state colleges that are just very welcoming to these, like notably Berkeley and, you know, the big name, the usual top 10 schools. And I think currently it's very likely that an indigenous youth who's going to seek higher ed needs to at least feel welcome, which would be a big first step. And the environment is not overtly hostile. And research upon what they're interested, including indigenous languages, be seen as a legitimate science. Because why haven't we solved this problem of polysynthesis? It's because the researchers speak English and they know it. They don't know how to solve it, but they don't care enough to fix it. And I've been fortunate enough to be working at a lab founded by Yosua Bengio, and he and his leadership has taken particular interest in this problem because, you know, Canadian context as well. And that's kind of rare. We need to change that dynamic. And I don't think we'll really solve what you're really getting at unless the TCUs are much stronger. And I don't know how to solve that at scale the way it needs to be. Maybe a conversation with Mark needs to happen. And I don't want to be like pushing a particular company, but that effort that he's working on Propel, I think offers potentially a method to empower the TCUs. But it's not going to be, there's no silver bullet, I don't think. Yeah. It's a big question.
Test.
Thank you very much. Round of applause, please. We are about to proceed. I want to see what the next sessions are called.